Hey guys, it's Andrew here again. And in the last video, we took a look at the first time going through VLSM, variable length subnet masks. And we looked at using magic number and breaking it down given some number of hosts on a network. And we're going to go through again, just yet another example of working through this. All right. So in this case, I've been given a network of 172.16.5.0/24. All right. And again, you can figure out what the actual network portion of this address is. /24, we can easily figure out right there. We have this 8 bits that are available to us for subnetting. So we have eight host bits that we can break down into smaller subnetworks. All right. And in this case, my boss is a jerk today, and he's given us this range, and he says he needs a network of 65 hosts, 6 hosts, and 2 hosts. I don't know what's going on there, but a 2-host network as well. Okay, so let's get started. All right. So first things first, we figured this out, right? I've got this all laid out here. We got our 8 host bits, all right? And we're going to then start to look, always work from the biggest to smallest numbers for the network. So we got this 65 network. So we're going to say, all right, given this 65 network, we're going to go through and we're going to start looking at each of my bit positions to find my magic number. So I got 65 here, and 65 can it fit inside of a network of not 128, 126, right? Again, this number minus 2 for our network and broadcast. So can I fit 65 inside of 128? Yes, I can. All right. So I can borrow this bit. All right. And then all right, I can borrow a bit there. And then I can say, can I fit 65 inside of 62? Nope, can't do that, right? So again, so I can only borrow 1 bit in this case. So my magic number for this network becomes 128. I've got 256. Again, I had 8 host bits, so my 2 to the 8th here, right? Total, and then I've got my 7 host bits, or my, again, 7 host bits, 2 raised to the 7th is 128, or again, where magic number comes into play, where the last 1 hits the 0. This 1 value is my 128, so I can divide it by my 128 and get the total number of networks, right? So I'll have 2 networks of 128, right? So let's do my best to split this down the middle, all right? So my first network here is this 128 in here, okay? And we can see that my 65, so I'm going to take my network and I'm going to bring it down here. So I got my 172.16.5.0. So again, we started at 0, so that's my first starting network. And then 0 slash, and then I borrowed 1 bit, so it's a /25. All right, and then we can see that if I'm going to remember with magic number, it'll give me my different ranges, right? So in this case, my first network is 172.16.5.0 right here, and then my next network over here is 172.16.5.128. Okay, so that tells me that my next network here down here, this guy, 172.16.5.128. Now, I don't know at this point what the slash notation is just yet. I do have to go and figure that out, but I do know where the network will start at the very least. All right, and then of course, remember at this point we've used this guy up, so this space here, it's all used up. Okay, it's all used up for that first network. It's in use now. Okay, can't make use of it. All right. So, taking a look at my next set of values here, I can quickly determine that my 6 here is my next biggest network. All right. So once again, don't forget about this second rule down here, where I always have to make the subnet as small as possible. All right. So can I fit 6 inside of 126? Yeah, that would work. But once again, I got 3 subnetworks, so I got to make this smaller, right? So I got to borrow a bit, okay? So I'm going to borrow a bit here, all right? Can I fit 6 inside of 62? Yep. that would work, right? I could draw a line here. I'd have 2 subnetworks. I could put the 6. I could put the 2. I'd be all set, right? Well, that doesn't satisfy my second rule. I have to keep going. I have to make it as small as possible. Again, we're paranoid. This is IPv4. We have to make this as small and tiny as humanly possible. All right? So we're going to borrow yet another bit. Okay? All right, so can magic, would 32 be my magic number, right? I can fit 6 inside of 32. That works, but could I keep going, right? And once again, I try again. Can I fit 6 inside of 14? Yep, that works. Okay. All right, so can I keep going? Gotta keep trying. Can I fit 6 inside of 6? Why, yes, I can. All right. So again, even if there's no excess and it works out perfect, sweet, right? You have no excess values. It looks like I nicked my magic number there. Okay. So borrowed quite a few bits to get down. All right. So I borrowed 1, 2, 3, 4, 5. Now I've got this down here. Got my 8, so 8 is my magic number in this case. Remember, I have 128 inside of this little block here, right? I've got my 128 in here for my last one. So I have 128 total that's left over, divided by my magic number, which is 8, gives me what? Well, what do you guys think? I think I'm going to cheat a little bit. All right. There's nothing wrong with using a little calculator here. Should be 16, but we'll find out. Just in case. 128 divided by 8 is 16. All right. So, again, if you're never not sure, right? I can now have 16 networks of 8 inside of here. So I will do my best to split this up. So we'll actually cut this down the middle, right? There's 2, 4, ooh, this is going to be tight. 8. Andrew, you should have made that bigger. And 16. 16 subnetworks, all right? And that means this guy here exists in this tiny little space right there, okay? So I know that my network is /28. I know I got 8 here, so I now have borrowed 1, 2, 3, 4, 5 bits, all right, on that /24. 5 plus /24 is 29, a /29. Really tiny network, okay? So what else could I tell you, right? We know this is, I started at 128, right? And I have a magic number of 8. So my 128 plus 8, right, is going to give me my new starting network, all right? So it should be 136. All right, 8 and 8 is 16, carry the 1. 13, 136. Again, never too proud to use a calculator. 128 plus 8, yep, 136, okay? Always double check your work, all right? So now I know that this network, 172.16.5.136, is the beginning of my next network, however big it may be, all right? And I can move on, all right? Okay, so let's find my I'm going to just, continue on here. I can find my next set of, my next set here. So I look at it and I say, I got a 2 down here. Can I fit a 2 inside of 6 usable hosts, right? Inside of this 8, right? Which gave me 2. Sorry, gave me 6, right? That would work. But could I borrow another bit? All right. Can I put 2 inside of 4 minus 2 is 2? I can do that. All right. So I can borrow one more bit. My magic number becomes 4. All right. And then I have, now again, I have 8 right there. That's 8. All right. Divided by magic number of 4 gives me another subnetwork. So it would almost be trying, right, which would leave this little tiny sliver of a subsection in here, right? All right, so again, there we go. We have our network. So we borrowed one more bit, and then that was a /29, so this guy is a /30. All right, so now we have our 3 different networks. We've taken our 172.16.5.0, and we've cut it up into tiny little pieces. One network of 65. Again, it's got quite a bit of overlap here. I've got to put it inside this network here of 128 or 126 total. It's just, it's as small as I could go. It's the smallest I could make it. All right. The 6 and the 2 line up perfectly with the 6 here and the 2 there. Just so happen to work out that nicely. And then again, as we're going through the networks, we can easily determine we started at 0 here. Then this one went up to 128. Plus the 8 brings me up to 136. So we've got our 3 different network addresses and their subnet masks that go along with them accordingly. All right. So I'll take a look at another example in the next video, where I'll actually break down an IP address, but this time we're not going to have this 0 here. We're going to have a different value that we have to work with. So I'll see you guys in the next video.